Have you ever wished upon a shooting star streaking across the night sky? Hi, I'm Jasmine Mugbelli, and I'm an astronaut living and working aboard the space station. I'm glad you've joined me today to talk about friction and how we use it in microgravity. Are you ready to learn about what's falling from the sky? Let's go check it out. Before we get to shooting stars, let's talk about friction. Friction is a force that tries to stop the movement of two things that are touching. It is the resistance objects experience while moving over a surface or through a fluid. It results from tiny imperfections to the surfaces when contact happens. There are three main types of friction: static, kinetic, and fluid. Static friction and kinetic friction occur between solid surfaces, while fluid friction is a resistance against a solid object moving through liquids or gases. When objects like rockets, for example, experience fluid friction in the air, we call it air resistance. Kinetic friction, also called sliding friction or dynamic friction, occurs when you have movement between two surfaces in contact with each other. If you've ever moved your chair in a classroom by sliding it across the floor, you've also experienced kinetic friction. Up here on station, we experience friction differently than we would back on Earth. If I were to move a piece of equipment or heavy cargo transfer bag, all I do is push and it floats wherever I need it to go. A moving cargo transfer bag would still experience air resistance since we have air aboard the space station. We experience kinetic friction on station when we write with a pencil. As the pencil is pushed across the surface of the paper, the pencil tip slides on the top of the paper, leaving a mark. Static friction acts on an object when it is in contact with another surface, but remains at rest. Your feet, for example, use static friction to help you walk. Your foot grips the surface so you can push yourself forward. If you tried to do the same thing on ice, your feet couldn't grip the ground and you'd slip. Most surfaces, like the bottoms of our feet, experience very little friction on ice. Here on station, we also use static friction, but in a different way. While we're in microgravity, we don't use our feet to walk like we do back on Earth. Instead, our legs and feet can be used to carry things, and our hands are used to navigate the space station's many modules. We also use our hands and feet to hook onto foot restraints and grab bars to keep us in place when we're conducting scientific investigations or recording video. Now, about those shooting stars. They aren't actually stars shooting across the night sky. Some are meteors entrapped by Earth's gravitational pull, causing them to fall toward Earth and burn up in the atmosphere, giving off that bright streak of light. Other shooting stars you've seen could be our re-entry spacecraft returning to Earth, or waste we expel out of the space station. A glowing spectacle is produced when the gas particles in the atmosphere and the fast re-entry speed causes the surrounding air to rapidly compress, which in turn causes the surfaces of the objects to heat up and glow. Re-entry spacecraft are designed to withstand that extreme heat and speed. Once the re-entry spacecraft is at a safe altitude to do so, parachutes are deployed to maximize its air resistance and slow it to a safe landing or splashdown speed. The space station waste and meteors burn up in Earth's atmosphere well before they pose a threat to life on the surface. Whether we're pushing chairs across a classroom floor, swimming in a pool on Earth, or moving something on station, friction is part of our everyday lives. Next time you see a shooting star, remember, it could be a meteor or something falling from the International Space Station. Either way, enjoy the marvels in our night sky. I'm going to send it back to Earth so you can experiment with friction using the corresponding classroom connection. Thanks for exploring physics with me today. See you soon.